right. Good morning, everyone, and welcome to the National Spectrum Management Association's 39th Annual Conference. This is our second day. For those of you who haven't been here before, NSMA was created 40 years ago at the behest of the FCC. At the dawn of the breakup of AT&T, it needed a belly button to push when it came to dealing between federal agencies and industry on how to ascertain whether or not there is harmful interference. And there had to be some sort of center of gravity where these issues could be discussed, where guidelines could be proposed, where folks could anticipate with new technologies, new bands coming online, and a variety of other new regulations coming online, and people could anticipate with some, reasonable certainty what might be provided for in terms of a way out of potential new harmful interference situations. So the NSMA has developed guidelines over the decades, many which have been adopted by the FCC as well. And this is a forum. It's both. It's unique in that it's a forum with both private industry and federal officials as members of NSMA. And we're always pleased this morning, as usual, to have a representative of the FCC's Office of Engineering and Technology. And today we have Nicholas Oros, who is the Deputy Chief of the Policy and Rules Division of OET. OET is the Commission's primary resource for engineering expertise. It provides technical support to the chairwoman, to the commissioners, to the FCC bureaus and officers. Since joining the Commission in 2005, Nicholas has been involved in various rulemaking proceedings, including the Spectrum Frontiers proceeding, which made the millimeter wave band spectrum available for 5G services. Also he worked on Spectrum Horizons, which focuses on spectrum above 95 gigahertz, and the 6 gigahertz band proceeding that made 1200 megahertz of spectrum available for unlicensed use. All of those prior proceedings have been front and center here at NSMA for a long time, so we appreciate Nick's work there. Prior to joining the Commission, Nicholas was an engineer at Motorola for 8 years, where he focused on computer simulation of digital communication systems and radio-based position determinations. He's a graduate of the University of Illinois College of Law. He's also earned a master's degree in electrical engineering from Purdue University and a bachelor's in electrical engineering from the University of Missouri at Rolla. So welcome, Nicholas. We really appreciate you coming on board.
Thanks for being here this morning. My presentation today is going to be on the regulatory proceedings of the FCC over the past year, and it's been a very busy year, so I guess I will get right into it. I would like to start out with a few proceedings that involve space. Just recently, the Commissioner adopted rules for supplemental coverage from space, or SCS, as we've been calling it. The idea here is that the satellite companies are going to be using spectrum, which is used by the wireless carriers, to talk directly to people's devices, smartphones, what have you. So, and of course, this is going to be used to provide coverage in areas, rural areas mainly, where there's coverage holes, but it's going to require cooperation between the wireless carriers and the satellite companies. So it's not like the satellite companies are going to be able to go and do this without any agreements with the wireless carriers. Now, in order to make this happen, the Commission added mobile satellite service allocations to many of the bands that are used by the wireless carriers. These include the 600 megahertz band, 700 megahertz, 800 megahertz, a broadband PCS, AWS H block, and sorry, little horse there. And in order to do SCS, the MSS licensees must file an application to modify their license along with a lease agreement that they have with the terrestrial license holder. The terrestrial licensee must hold a license for a particular frequency band in what is referred to as a geographically independent area. So there are 6 of these geographically independent areas defined in the rules. The largest is the contiguous United States, but there's also Alaska, Hawaii, and then some of the territories like American Samoa, Puerto Rico, Guam. The idea behind this is that there shouldn't be interference issues across geographic boundaries between the licensees. So that's why they're requiring one licensee, terrestrial licensee, to have control, say, of the entire United States, so that that's not an issue across the geographic boundaries. So either a satellite company has to have an agreement with that single licensee, or they could also reach agreement with multiple licensees which cover the entire geographic area. Now, the technical rules that were adopted for SES are designed to prevent harmful interference from happening to the terrestrial users. So, that's they're really, front and center here, and their service isn't going to be affected by this at all if things are working like they should. There are 2 types of power limits that have been adopted. There's a aggregate out-of-band emissions power flux density limit of minus 120 dBm per meter squared per megahertz. And then there's also field strength limits at the Earth's surface. And these are consistent with the limits that currently apply across geographic boundaries between terrestrial licensees in the current service rules. To protect these adjacent service areas, including the international borders, which is a big issue, the power is limited to 40 decibel microvolts per meter below 1 gigahertz and 47 dBm microvolts per meter above 1 gigahertz. The US has an obligation under the ITU radio regulations, rule number 4.4, to protect the terrestrial services across the international borders. So there's this particular concern across the Canadian and Mexican borders in particular. Now, there was a further notice of proposed rulemaking to kind of clean up some issues that are still outstanding. One of the big issues was protecting radio astronomy. Under the current rules, this is going to be addressed when the satellite companies ask for their license to be modified in order to provide SCS. So that's going to be done on a case-by-case basis, to protect individual radio astronomy sites. But in the further notice, the commission is asking, well, are there any rule changes that need to be made specifically to protect radio astronomy? And does any sort of formal coordination process need to be set up? The commission also sought comment on 911 issues. When you're talking about a satellite service which has a fairly broad footprint, it's not straightforward to route your 911 calls to the nearest public safety answering point. So the commission's asking comment on, is there anything that needs to be done to try to make that work more smoothly? Because people are still going to expect that their 911 calls get routed appropriately. There has been some interest already in the SCS. SpaceX has requested experimental license to do some testing at 25 locations around the United States. They're doing this in the 1910 to 1915 band, basically the H block, and they're doing this in conjunction with T-Mobile. So, we expect that probably all the wireless carriers are going to make agreements with satellite companies in order to offer the SCS service. Now, another space-related proceeding that we had in the past year was spectrum allocation for non-federal space launch operations. Back in September of 2023, we adopted a second report and order and second further notice of proposed rulemaking for this band. There were two bands where we added allocations as part of this proceeding. For the 2025 to 2110 megahertz band, we added a secondary space operations allocation in the space to Earth direction. This band is limited to being used for telecommand for pre-launch testing when rocket launches happen. This has been used a lot by SpaceX. They regularly, with their Falcon 9 rockets, they launch them into space, and then once the rocket separates, it's actually brought back down to Earth and lands either Cape Canaveral or on a barge out at sea. And they use this band in order to send the command signaling to the rockets. So this has been used under experimental licenses in the past. But now that we're adopting allocations and service rules, we're going to be able to provide licensing for this type of use. The other band where we changed allocation was the 2200 to 2290 megahertz band. In the previous reporting order a few years back, we had added a secondary space operations service allocation in the space to Earth direction, as well as a mobile service allocation to this band. But its use was highly restricted. It was just limited to 4 specific subchannels in that band. So in this latest reporting order, we removed that limitation to the 4 subchannels in order to give more options to the space launch companies for using the band. Now, under the rules that are being adopted or have been adopted back in September, they're really just limited to use during the space launchings and then for pre-launch testing before the launches occur. They're used for purposes such as vehicle tracking, including transmitting data from a launch vehicle to the ground, so that's telemetry. And then they're also used for telecommand, for propulsive maneuvering and separation of the payload from the launch service. As I mentioned, SpaceX is doing that. Now, both of these bands are shared with a lot of other users. The 2025 to 2010 megahertz band is shared with the Broadcast Auxiliary Service. This is used for TV pickup by the television broadcasters for providing live news feeds from the scenes of breaking news events. That's probably the heaviest use, but there's also a number of federal uses to the band. NASA has earth stations, DoD has earth stations for uplinks in the band, and then there's some fixed and mobile military systems too, particularly used around military bases. So all of these uses have to be coordinated under the rules. So what the rules adopted do is they set up or rather they have provisions to choose a third-party coordinator, and the coordinator hasn't been chosen yet, but there is going to be a third-party coordinator that's going to be chosen, which is going to do the coordination with both the TV broadcasters and with the federal government in order to make sure that both of these spectrum bands are not going to be causing interference resulting from the space operations. There were technical rules adopted, and these technical rules in terms of the power, the out-of-band emission limits, they're based on what has been in place for federal systems, since there have been federal space launches occurring using both of these bands for many years. So basically, pretty much the same technical rules were adopted in the Commission's rules as had been in place before for these previous launches. Now, there also was a second further notice, and this seeks comment on adding a number of footnotes to the table of allocations, which would provide allocations for use during manned space missions, going to say like the International Space Station. And then it also seeks comment on possibly more intensive use of the 2300 megahertz band during space launches. That band has been available in the Commission's rules for, I guess, since the late 90s, but it's seen very little use for this purpose. So the Commission is seeking comment on potentially making more use of that band. Now, there's been a lot of interest in mid-band spectrum by the wireless industry over the recent years. So I'm going to talk about a few mid-band spectrum bands. The first one is the 3.7 to 4.2 gigahertz band, or C-band as most people call it. Now this is a band which has mainly been used by satellite downlinks, mainly providing video feeds to cable television head-ends, for example. There are stations all across the country for doing this. Under the rules that the Commission adopted a few years back, the lower 280 megahertz of this band is being made available for mobile broadband. So this is going to be for 5G systems. And then the upper 200 megahertz is going to remain available for satellite purposes. So the satellite use is being compressed. Now, in order to make this happen, additional filtering had to be installed on all of the satellite earth stations in the band. And fortunately, this has now been complete as of late last year. So the wireless carriers are now able to start deploying in their 280 megahertz of spectrum. And from the reports we've had, they are really rolling it out aggressively now. Now, one of the ongoing issues with this band has been the potential for interference occurring to radio altimeters. These use the band above 4.2 gigahertz, so it's above the satellite downlink band, about 220 megahertz away from where the 5G systems are going to be operating. But there's still concern that potentially this could cause interference with altimeters, which are used to determine the altitude of aircraft. There has been put in place a voluntary agreement between the wireless carriers and the airline industry in order to help protect these radar altimeters. And this was put in place starting in July 2023. RTCA, which is the standards organization which develops standards for aviation-related systems, they've convened a standards group which is going to develop new standards for radio altimeters so that this won't be an issue in the future. And there's also been quite a bit of testing of these altimeters. There is a joint interagency group called the 5G Radar Altimeter Interference Group that conducted testing, and then there's also been testing conducted in a number of countries around the world. So a lot of people have looked at this issue. The FAA required that the altimeters in commercial aircraft be upgraded, and this was completed in September of last year. So, the thinking is now that this really isn't going to be a problem going forward. Now, I mentioned that the wireless carriers had made an agreement with the aviation industry on how to protect the altimeters. This requires that as of January of this year, base stations can now operate at the full power which is permitted under the rules. So that's 65 dBm per megahertz in rural areas and 62 dBm per megahertz elsewhere. However, the base stations have to implement restrictions on the amount of energy that they transmit upward. So for transmissions above the horizontal plane, they're required to reduce their power by at least 14 dB from those maximum power levels. There's also a requirement that they coordinate their base stations near 188 high-priority airports. And this coordination is going to be using a signal and space model that the FAA developed. This model is based on measurements, basically, of the altimeter's ability to filter out out-of-band signals. There's a set of power spectral density curves that have been set up. And as I mentioned earlier, the FAA had required altimeter upgrade replacement for certain altimeters that really were not meeting their requirements. And this has already been completed. The agreement also put in place out-of-band emission requirements. For outdoor 5G equipment, there is a maximum minus 48 dBm per megahertz conducted spurious emission limit. And for in-building equipment, this is a minus 30 dBm per megahertz limit. Now these limits in the agreement, they expire in January 2028, but there are provisions for it to be extended or modified if it's needed. Now moving down in frequency to the band below the 3.7 gigahertz band is the 3.55 to 3.7 gigahertz band, which is used by Citizens Broadband Radio Service, or CBRS, everyone refers to it as. This is sharing of 150 megahertz of spectrum with both Navy radars, which use the band extensively, and then there's a number of satellite Earth station downlinks that also have to be protected. This dynamic sharing system regime has been in place since January of 2020. Now in CBRS, there are 3 tiers of users. There are the incumbents, which the Navy radars and Earth stations. Then there's priority access licensees. They obtain their licenses at auction, and they get the right to use a certain amount of spectrum in a particular geographic area. And then at the lowest priority are the general access licensees. And in a lot of ways, they're similar to unlicensed operators. They don't have any interference protection rights. They just get a nationwide license and they can kind of operate anywhere. Now, there's been quite a bit of deployment of CBRS equipment. NTI did a study back in May 2023, and they found that there were almost 300,000 CBRS base stations deployed out there at that time, and that this was growing at about 12% per quarter. So that number's, significantly bigger by now, we would presume. The general access licensees are the most common, but the priority access licensees are actually growing at 17% per quarter. So there appears to be increased interest in them. Most of this usage that's been out there has mainly been in the rural areas. And there is a growing market for CBRS devices. As of March of this year, there are 267 equipment certifications for CBRS base stations in the FCC's equipment database. And there's 731 certified end-user devices. So there's definitely a lot of equipment available for this currently. CBRS has seen uses for a lot of different use cases. It's been used by private networks, by neutral hosts in buildings, for example, by 5G, and by Internet of Things devices. Now, there have been a couple changes to CBRS just in the past year that I want to mention here. Recently, OET and the Wireless Bureau jointly granted a waiver to require the spectrum access systems, which manage the frequency access in CBRS, to use a Department of Defense operated online portal And this portal tells the spectrum access systems when there's going to be use of spectrum in particular areas by DoD systems. This is going to permit the spectrum access systems to manage access to spectrum around defense facilities such as test ranges when the testing, when the ranges are actually in use. And then, of course, the rest of the time, it's going to be available for the CBRS users. This also permitted CBRS to begin operations in Hawaii. Up until now, there hasn't been CBRS usage in Hawaii because there were no what are called environmental sensing capability devices there. And these are the spectrum sensors which listen for when the Navy radars are in the area, and they tell the spectrum access systems that the CBRS devices have to vacate the spectrum. So because there weren't any in Hawaii, CBRS has not been able to be used there until now. But now that there's this online portal that can help manage the spectrum use, CBRS is now able to deploy. The Navy has retained 30 megahertz of the spectrum that they want to be able to use all the time, but the rest of the spectrum is now available in Hawaii to be used, except for when the radars are actually being actively using the band. Something else that has happened, the Wind Forum has updated the CBRS technical specifications. There were a couple of new features of this specification. There was a new propagation model which has been put in place. Previously, CBRS used the irregular terrain model, which is a very common model that's been out there for a long time. But the new model that they're using, it's particularly useful in urban areas, and it's really reducing the size of the areas that cannot be used when radars are present in the area, when radars are detected. And it's thought that it's going to allow about 72 million more people to potentially use spectrum, just because the areas that are going to be restricted are going to be reduced by such a large amount. Now, another change that's being made is that the CBRS base stations that are located outside of what are called dynamic protection areas are going to be able to reduce how often they have to check for frequency assignments. Dynamic protection areas are the areas along the coast. So they're the areas where you would expect Navy radars to potentially be operating, and the spectrum might have to be vacated. So when you're outside of those areas, the base stations are now going to have to only check for the frequency assignments once per day. The current rule is that they have to check for frequency assignments at least every 5 minutes. So this is going to really reduce the amount of traffic in the network and the amount of checking that the CBRS base stations have to be doing. Now, both of these changes aren't going to be implemented immediately. Before they can actually be rolled out in the CBRS networks, they're going to have to undergo testing. Now, moving down to the band immediately below CBRS, the 3.45 to 3.55 gigahertz band. This is a band which was auctioned back in 2021 for almost $22 billion. Over 4,000 licenses have been issued for this band, and deployment has begun of 5G systems in many places. Now, this band is still shared with some federal systems. It has in the past been used by a tremendous number of federal systems. Some of them vacated the spectrum, but they do remain in certain areas. There are two types of areas where federal use is going to continue in the band. There are cooperative planning areas, and these are areas where the terrestrial licensees have to reach coordination agreements with the federal users in order to use the spectrum in those areas. And a lot of these are around military bases or test ranges, places where there's going to be a lot of federal Department of Defense activities. There are also periodic use areas, and these are areas where the federal systems have a right to use the spectrum for a limited amount of time each year. And this use is scheduled in advance, and that way the wireless licensees are able to plan for use of the area potentially. Now, in this band, there's quite a bit of fixed and mobile federal systems, some federal radar systems as well. But outside of those two types of areas, it's now available for full power use by the terrestrial licensees. There is now a Department of Defense online coordination portal, which is active and is going to allow coordination of these areas, hopefully in a much more straightforward and easy fashion. The wireless carriers in the Department of Defense continue to work on making deployment in these two types of areas easier, and hopefully that there's going to be more deployment in the future. So that band has really seen a lot of use already. Now, just below that band is the 3.1 to 3.45 gigahertz band, or the lower C band. And this is a band which is receiving a tremendous amount of interest from the wireless industry. They would really like access to this spectrum for 5G. It's a band which is heavily used by Department of Defense systems, especially radar systems. Back in September of 2023, the Department of Defense released a study on potentially sharing of this band called the Emerging Midband Radar Spectrum Sharing Report. And this report reached a conclusion that 5G commercial systems cannot operate in the same frequency band at the same time as federal government systems without unacceptably degrading those federal government systems. This report did suggest a couple of ways that sharing, could be done. It suggested, potentially expanding the existing CBRS sharing framework. So this is basically be CBRS, but probably much more complicated because the sharing environment is much more difficult here. The Department of Defense really stressed in the report that they really need to maintain regulatory primacy in this band, just because these systems are so important to their mission. And they also say that it's very important that interference safeguards be established for these spectrum sharing systems. And even with such a system, they say it's really going to be challenging to share the spectrum, that it's going to take a lot of development and testing in order to make this happen. So, overall, it's really not that positive for being able to share the band, unfortunately, which, disappointed some folks, but it is what it is, I guess. More recently, NTIA has issued a implementation plan for the National Spectrum Strategy, which includes doing an additional study of this band. And this study is going to be conducted jointly by NTIA and the Department of Defense. Its scope is going to be a little broader than the previous study. So the previous study just studied potentially sharing the band with all the federal systems staying in place as they are. This new study is going to look at some additional options, such as potentially moving federal systems out of either the whole band or part of the band, compressing the frequency ranges used by the federal systems, looking at maybe getting access to spectrum below 3.1 gigahertz for the federal systems, which would allow them to potentially move down and free up spectrum in this band. And it's also going to look, more broadly at any other type of ways to free up spectrum in this band. Now, as part of this study effort, the Partnering to Advance Trusted and Holistic Spectrum Solutions task group is being reconstituted as part of this study effort. So this was the group that was set up by the Department of Defense for the previous study. It includes representatives of both industry and the Department of Defense, and the idea here is that they would exchange information, develop, use cases, get the actual technical parameters of the systems, and try to identify sharing scenarios and use cases for using this band. So, the idea is, again, to work with industry on this new study. Well, as I mentioned, NTI has come out with a national spectrum strategy. And of course, this is a NTIA initiative rather than FCC, so I'm not going to really go into it in detail, but I did want to mention a few things about the national spectrum strategy. As I mentioned, there is a requirement to do some studies on some different bands. 5 different bands have been chosen for studies. First one I mentioned already, the lower 3 gigahertz band. And there's a deadline for this study of October 2026. So it's going to be a few years before this study is completed. The next band is the 5030 to 5091 megahertz band. And I'm going to talk about that band in a little more detail on the next slide. That study is scheduled to be complete a little earlier, March of 2026. The 7.125 to 8.4 gigahertz band is scheduled for completion in October 2026. So this is another band which the wireless industry is really, really interested in, potentially getting their hands on for 5G and potentially 6G in the future. That band is used for a lot of point-to-point microwave links by federal government agencies. There are also satellite earth stations and a number of other systems in that band. So, sharing or relocating, again, may be complex, but hopefully this will lead to spectrum being released in that band. The 18.1, the 18.6 gigahertz band is scheduled for completion of May of 2025. So that's going to be a lot sooner. This is a satellite downlink band, and then there are also point-to-point microwave links, although much fewer links than are, say, in the 7 and 8 gigahertz band. And then the 37 to 37.6 gigahertz band is scheduled for completion later this year in November 2024. This is a band which has been part of the Commission's Spectrum Frontiers proceeding in the past. In fact, the Commission back in, I believe it was 2018, sought comment on federal and non-federal sharing for that band, but rules have never been adopted for that. So, hopefully this study will help push that process along and bring that to completion. Now, in addition to these spectrum studies, the National Spectrum Strategy also had a number of other components. It's implementing a long-term spectrum planning process. It's establishing a roadmap for improving receiver resistance to interference, which could be useful. It's developing a national spectrum research and development plan, which I guess is only useful if there's money for that at some point, but that could also lead to advances in the area. And then they want to do an advanced spectrum sharing demonstration project and issue a report on this. So, the idea is kind of the next generation beyond CBRS, more complex forms of dynamic spectrum sharing. Well, as I mentioned on the previous slide, the 50, 30 to 59 megahertz band has been under consideration for a while by the Commission for use by unmanned aerial systems. Back in December of 2022, the Commission adopted a NPRM that's proposing to allow two different types of systems to be used to control unmanned aircraft systems. There is what's called non-networked systems. These are used for line of sight operations. So here, the controller of the unmanned aircraft or drone is within sight of the drone. There are also networked operations, and these are for use for non-line of sight conditions, potentially even including handoff from one base station to another. So this might look more like the wireless carriers networks, for example. This spectrum under the proposal would be used only for control and non-payload communications, because the recognition is that there could be a lot of demand for spectrum for drone use in the future. And this isn't a tremendous amount of spectrum, so they do want to limit it for this purpose only. A dynamic spectrum frequency management system would be set up to manage access to the spectrum for both types of uses. The Commission also proposed service rules and types of permissible services that could be offered under this. Now, there was also an inquiry on whether the wireless carriers networks could also be used to control drones. So that would take some of the load off of this spectrum. And then there's also a proposal to potentially use VHF aeronautical spectrum for that purpose as well as using this spectrum. Currently, there is a reporting order on this topic on circulation to the FCC commissioners. Now, FCC items that are on circulation, unfortunately, are not released to the public, so I can't really give any details of what's in there. But, it does tell you that, maybe in the near future, we're going to see action on this band and rules actually be adopted. Now, the 5.9 gigahertz band is a band from 5.895 to 5.925 gigahertz. Back in July of 2021, the Commission adopted rules which took part of this band, which had been used by the Intelligent Transportation Services since the late 90s. It was allocated for that purpose. But unfortunately, these systems never really have been deployed to a great extent. So the Commission back in 2021 took the lower 45 megahertz of this band and made it available for unlicensed devices. And this is now referred to as the Uni-4 band. The upper 30 megahertz of this band has been retained for Intelligent Transportation Services. And the proposal was that this now be transitioned to technology called CV2X. The further notice did propose technical and service rules for CV2X and also a timeline for making this transition. It also proposed to allow the unlicensed use in the lower portion of this band to occur outdoors. Under the current rules, it's limited to indoor only use. And the reason for that is that there are a number of federal radar sites that are present in both portions of this band, so those have to be protected. So the further notice sought information on how those could be protected from both the CV2X systems and the unlicensed systems. Now, the final rules for CV2X have not actually been adopted yet, but the Commission has issued a number of waivers last year and this year too, to allow automotive manufacturers and State Department of Transportations to start deploying these CV2X systems in the upper 20 megahertz of spectrum. Oops. Okay. And there actually are additional waiver requests that are pending currently. So there may be more issued in the future. However, of course, the final technical rules still need to be adopted. And then the commission still has to deal with, well, how to protect these federal radar systems as it adopts these final rules. And it also needs to finalize that timeline to having the transition to CV2X occurring. The next band I would like to talk about is the 6 gigahertz band. Now, back in 2020, the commission adopted rules to permit 2 types of unlicensed devices to operate in this band. In 850 megahertz of this spectrum, so 2 distinct portions of the band, the commission's rules permit standard power devices to operate. These devices operate under an automated frequency coordination system, or AFC, as they're called. The AFC determines the frequencies that the devices can use and the power levels that they can operate. The other type of device that is permitted are the low-power indoor devices. So these operate across the entire 1200 megahertz of 6 gigahertz band spectrum. They're restricted to indoor use only, and they operate at significantly lower powers than the standard power devices. Now, the AFC systems, as I mentioned, determine the available channels and maximum power that standard power access points may operate at. To protect the fixed point-to-point systems in the band, these AFC systems access the Commission's Universal Licensing Service database to get information on where point-to-point microwave receivers are located. They then use propagation models that are specified in the rules in order to calculate what the permissible power levels would be. There are 3 different propagation models that are specified in the current rules. For distances less than 30 meters, free space, a propagation model is used. For distances from 30 meters to 1 kilometers, the Winner 2 propagation model is used. And for distances greater than 1 kilometer, the irregular terrain model is used. The AFC systems also check that the FCC ID of the standard power device is in the FCC's equipment database, just to kind of double check that this is a device that actually has been certified for operation in this band as a standard power device. Now, something that has occurred fairly recently, February of 2024, the first 7 AFC devices have been approved, AFC systems have been approved for operation. This was done after an extensive testing process. 2 types of testing was done. There was lab testing, and this was done using a set of test vectors that were developed by the Wi-Fi Alliance and the Wind Forum together, and it was done by FCC recognized testing laboratories. And then there was also public trial. So each of these AFC systems set up a web portal, and anyone was able to go in and put in coordinates and see what the AFCs would return in terms of frequency assignments and power levels at that location. Now, as a condition for these AFC systems be approved, the commission, or OET, rather, not commission, OET, required that by April of this year, that these AFC systems implement an interference reporting portal for receiving and processing potential interference reports that are received. And that portal is up and running. There are standard power devices that have been certified I don't know if any are actually available on the market. Wasn't able to actually find anything, but hopefully sometime in the near future, now that the AFC systems are operating, people are going to be able to start taking advantage of these AFC systems. We also received one additional application for an AFC system from C3 Spectra, and they're going to have to undergo that same two-part testing process before their system is approved for commercial operation. There also were 6 AFC systems that initially applied, and they received conditional approval, so their applications were judged acceptable, but they still have not gone through the testing process. So at some point, we may see some additional AFC systems from that group as well. Now, back in October of 2023, the Commission adopted additional rules for the 6 gigahertz band unlicensed operations. A third type of unlicensed device, very low power devices, is now allowed under the rules. These devices may operate in those same 2 portions of the 6 gigahertz band where standard power devices operate. So these are the Uni 5 band, which is from 5925 to 6425 megahertz, and the Uni 7 band, which is from 6525 to 6875 megahertz. These devices are permitted to operate at any location, indoor or outdoor, and they do not require an AFC connection in order to operate. The technical rules put in place for very low power devices are as follows. They're restricted to a maximum power spectral density of -5 dBm per megahertz, and they can have a maximum EIRP of 14 dBm. There is also an out-of-band emission limit for outside of the 6 gigahertz band of -27 dBm per megahertz. There are also a number of restrictions placed on VLP operations. They're required to employ transmit power control to help reduce their power levels. They're not allowed to be used for fixed outdoor uses. So the idea is that these are going to be portable devices, portable, pretty much battery powered, carried around by people. That sort of application is what people are thinking of here. They're also required to prioritize operations above 6105 megahertz prior to operating at channels below that. And that's to help protect the CV2X operations, which are in the band immediately below 6 gigahertz. Now, when the Commission adopted the report and order changing these rules, it also addressed a remand from the previous rules that were adopted back in 2020. In the remand, the claim was that in the 2.4 gigahertz band, the unlicensed devices there were causing interference, and because of that, the Commission should reconsider or adjust the rules adopted in 6 gigahertz. The Commission here decided that, well, that was interference complaints really weren't substantiated, so there wasn't any need to change their rules. So that issue was resolved as well. Now, the Commission also had a proposal for making some additional changes regarding very low power devices. One proposal is to increase the power levels permitted for operation of these devices. They're allowed -5 dBm per megahertz currently, and the proposal is to increase that up to 1 dBm per megahertz, but maintaining the 14 dBm EIRP total power. Now, in order to do this, the VLP devices would have to operate under a geofencing system. So this would be, in a ways, it's kind of a similar idea to the AFCs that control standard power operations. They would be prohibited from operating on certain frequencies in particular areas, in order to protect the incumbent users in the band. The further notice also proposed increasing this power up to 21 dBm, again, for geofenced systems. So the geofencing system would have to take that increased power into account when it determines the size of the geofencing areas. The rules, right, the proposed rules here for geofencing are pretty consistent with what's already in place. So there's going to be the transmit power control limit. The out-of-band emission limits would remain the minus 27 dBm per megahertz. And the same propagation models that are used by the AFC would be used by the geofencing systems in order to determine the excluded areas. The proposal allowed quite a bit of flexibility for these geofencing systems. So one option is a centralized approach, which would look like the AFCs do. So there's a server out there on the internet which does all the calculations of the exclusion areas, and the devices would just contact that server and download information for the area where they're at. There could also be a decentralized architecture where the actual very low power device does a lot of those calculations on its own without the need for this central server out there. In addition, the further notice also proposed to expand the existing very low power devices operation, which is at the minus 5 dBm per megahertz power, to the remainder of the band. So these are what's called the Uni 6 and the Uni 8 portions of the band. These are portions of the band where broadcast auxiliary service operates. It's live news feeds, feeds from cameras back to the truck at news events, that sort of thing occurs in that band. An additional topic, which was in the further notice, was whether the out-of-band emission limits below 6 gigahertz need to be adjusted in order to protect CV2X operations, which are just below this 6 gigahertz band. Moving away from the 6 gigahertz band now, now I'd like to talk about the 12.2 to 12.7 gigahertz band. This is 500 megahertz of spectrum, which is mainly used by the direct broadcast satellite service. So this is DirecTV and Dish Network providing video service to consumers' homes. And it's also used by non-geostationary satellite service downlinks. Starlink in particular has started using this band quite a bit. There was a commission proposal to potentially expand use of this band for mobile broadband uses, but back in May of 2027, the commission declined to authorize this two-way high-power terrestrial type service in the band. Now, while it did decline to make this change, the commission did seek comment on a number of other options for more intensively using this band. One proposal is to permit increased flexibility to the terrestrial systems that operate there. There is a system called MVDDS, which is currently permitted to operate at the band. It's a very low power, kind of a point-to-multipoint type system. The idea was to be consumer service. It's really not deployed very many places. So the idea here would be to upgrade that in order to allow more power, either on a point-to-point basis or a point-to-multipoint basis. But the idea would still be to protect the satellite services from receiving interference. So it would be challenging, but it is the proposal. There's also a proposal to permit two-way point-to-point links. The MVDDS is just a one-way service currently. And then there's also a proposal to potentially have an unlicensed underlay, maybe an indoor-only use, if you could get the powers right, maybe you could still protect the satellite use, but allow some additional use of the band. Now, in that same further notice, the commission also made a number of proposals regarding the 12.7 to 13.25 gigahertz band. And this was following off of a notice of inquiry, which was done the previous year. Now, currently, this band is allocated for the mobile, fixed, and fixed satellite service use. There's some fixed point-to-point links here. There's some TV pickup, basically TV broadcast auxiliary service, live news events type use here. And then there's also some limited federal government use. NASA has a Earth station in Goldstone, California, which is used for receiving signals from, deep space. So really weak signals. So needs a high level of protection. So the proposal here is to potentially make some or all of this band available for mobile broadband uses. So the existing users would either be grandfathered in place or perhaps relocated to other bands, or another option is potentially repacking them into just a portion of the band or making the rest of the band available for the mobile broadband uses. One specific proposal is to limit the broadcast auxiliary uses to just 25 megahertz of the spectrum, and then freeing up the remaining 525 for mobile broadband. The further notice invited commenters to explore sharing methodologies between the incumbents and new entrants. And it also seeks comment on protection of both that in-band federal use and then the adjacent band federal use. And particularly above this band, there's quite a few federal systems. So that's going to be an issue. And then protecting the satellite receivers in the lower band below this may also be an issue that occurs. The further notice did seek comment on potentially using a database approach, so CBRS or AFC type system in order to share the band. Another band that the commission did a notice of proposed rulemaking on last year was the 42 gigahertz band. There were 3 different proposals made for potentially licensing these bands. One is having a nationwide non-exclusive licensing approach. So the licensee would get a license, it would be non-exclusive, and then they would coordinate and register their individual base stations or point-to-point links in a database, which would be run by a third party. Another option is a site-based licensing approach, where they would just register their individual licenses directly with the commission, placed in the database, coordinated if necessary. And then a third approach is some sort of technology-based approach. So, maybe something like, an AFC or spectrum sensing. And the reason that, these 3 particular methods were outlined is, of course, right now the commission does not have spectrum auction authority. So, this was kind of outside the box thinking, what could we do to get this spectrum out there without having exclusive geographic licensing, which we're required to do an auction in order to issue those licenses, which we can't right now. The proposal here for the licensing is to have 5 100 megahertz wide channels. Now, one of the issues here is going to be protecting radio astronomy, which is in the band immediately above this. So, out-of-band emissions into that band is, potentially going to be a problem, especially near those radio observatories. Another accomplishment last year by the commission in May, the commission adopted rules for the 60 gigahertz band to permit short-range, low-power radars to operate. This is a band which has been used by unlicensed communication devices. The WiGig standard has been created for devices in that band. Not a tremendous amount of use, but there is some use for that. What these new rules did is that they allow these, what are referred to in the rules as field disturbance sensors, which is the Part 15 term for radars. It's going to allow them to operate throughout the band. However, the rules adopted power levels that were very restrictive in certain sections of the band and more permissive in others. And the idea here is to encourage the radars to operate in the lower part of the band and encourage the communication devices to operate in the upper portion of the band. So without, excluding them explicitly, the thought is that that sort of sharing is going to happen between those two uses, because there's a lot of concern that they're just not going to be compatible with each other. So there are, fairly complex rules in terms of the ERPs permitted in different portions of the band, the duty cycles permitted as well. Now, something else that these rules allowed is allowing these radars to operate on unmanned aircraft. So this can be used, by drones in order to help them avoid obstacles. The Commission adopted some updated rules for the 70, 80, 90 gigahertz band back in January of this year. Now, one of the major changes to the rules is that we're now going to allow endpoints that are in motion here. This band, it's used by a fairly large number of point-to-point microwave links. And then there are also some satellite earth stations, both uplinks and downlinks in the band, and some federal government systems as well. With these new rules, they're designed to allow data links to aircraft in ships. So you have base stations on the ground sending data up to the aircrafts, and then the signals can be sent hop to hop from aircraft to aircraft. So you can think of kind of a moving mesh network in the sky. And this would happen above all the point-to-point links, which are occurring down at ground level. So, the idea is that this should not interfere with those point-to-point links that are in place. So for these air-to-ground links, the rules establish some separation distances. From the earth stations, they're required to be 10 kilometers away. And from radio astronomy sites, there's some radio astronomy bands that are adjacent to, both the 70, 80, and 90 gigahertz bands. So that's a real concern. They have to be 150 kilometers away from the radio observatories. They're also required to maintain at least a 5-degree elevation angle aiming up to the aircraft. And that's just to keep them from pointing into the microwave receivers that are aimed along the ground. Now, for the air-to-air links, there are stringent out-of-band emission limits, which is to protect those passive services and radio astronomy and the nearby bands. And then there's also a limit on the power within 375 kilometers of certain military installations, because there are some federal systems out there that need protection. This use on aircraft, it's limited to when the aircraft are between 10,000 and 50,000 kilometers. And again, that limit is to keep them away from the point-to-point links. And there's also a limit on how close the aircraft can be when they're at different altitudes. They have to be at least 50 kilometers away from each other before they can actually have an air-to-air link. Now, there are also rules specific to using these on ships. For ships, the links from the shore to the ships are from the shore up to an aerostat are in the 70 gigahertz band. and going from the ship to the shore is in the 80 gigahertz band. The ship-to-shore transmissions must occur at least 30 kilometers away from the shore, or if they're within 30 kilometers, they must be pointed at least 15 degrees away from the shore. And that's to avoid any interference to any microwave receivers that are located on land. There is also a 150-kilometer separation distance from certain federal facilities in the rules. Now, in addition to these new rules for the endpoints in motion, was also a relaxation in the antenna gain requirements. And the idea here is we want to permit people to use smaller, lighter antennas to encourage more deployment of fixed point-to-point links in this band. The antenna gains were reduced from the current 43 dBi down to 38 dBi. And then there's also a reduction in the copolar and cross-polar antenna discrimination requirements, again, to permit much smaller antennas to be used. Let's see what, I'm just thinking here, when was my end time? 10:45. I'm actually over. Okay, so why don't I take some questions here then, quickly. Sorry, I thought that would be much quicker. Oh, yes.
First of all, you had to boil an ocean. You did a great job. Oh, thank you.
If you could introduce yourself, and it's for the audio of the video, that'd be great.
Okay, can you hear me now? Okay, great job. Does the FCC or NTIA, or both of them, going to lead an effort starting now, not 2-3 years from now, on defining, the government, the DoD's spectrum pipeline? There's this talk, spectrum pipeline by the mobile network operators, and I think they're doing a good job asserting that. But if there's nothing to engage in the SSS, what's the pipeline on the government side? I think you can see it. It gets harder and harder to manage this. Do you have any comment on that?
Well, obviously getting more spectrum available, establishing a pipeline is getting harder and harder, right? The easier bands have already been done. Other than what's in the current, spectrum, national spectrum strategy implementation plan, I don't think there's any specific activity going on right now for that.
And don't you see a need for that? What does the government going to need to fulfill its critical mission going forward? Just like the MNOs say, hey, I need this additional spectrum.
Well, I think in the implementation plan, there was the idea of establishing a spectrum strategy, right? That was one of the tasks. So I think NTIA is thinking about establishing that sort of process is how I read the plan. Now, what that's actually going to look like, of course, is up to them. I haven't heard anything more specific than what's in the plan at this point.
Do we have any other questions? Dr. Willis.
Hi, Tom Willis, AT&T Labs. First, let me thank you for coming to speak to us. It's always great to have some insight as to what's going on at the OET here at our annual NSMA meeting. So thank you very much for coming to talk to us. My question is regarding the 6 gigahertz band and the new rules that keep coming in there. And at least from my perspective, it seems like the rate that new rules are being introduced in the 6 gigahertz band is coming at a pretty good clip. Back in 2020, we had the VLP or the LPI devices coming in there and also the standard power devices. And it took us a little while to get the AFCs, set up, but now they're, at least authorized to operate. And we've also now got new rules on VLP. And while all this is going on, we've got, new further notice talking about geofenced unlicensed devices and stuff. So it seems like, even before we get the last rules implemented to see how it's going to, how that's going to shape out, we've all got proposals for even new rules coming in. And I guess my question from you is this just sort of like the new norm now for the 6 gigahertz band and other bands? Or do you see that maybe this is going to slow down eventually, that, we'll get all the changes that people have proposed in and discussed and figure out how we're going to do that, and maybe things will kind of slow down a little bit? And don't get me wrong, because it's been keeping me gainfully employed for several years at AT&T to work on these things, but I was just curious if you had some insight into, how that's going to shape out going forward into the future.
Well, it's also kept us very busy too, so I mean, that's good too. Yeah, it really has been, quite a bit of work that we've done over the past few years on 6 gigahertz. And I think, we have a further notice on the table, so we can expect at least one more round, right, of rules. But I don't think anyone's really proposed anything beyond very low power at this point. I haven't seen any proposals from anyone in industry, and we really, haven't talked about it internally much. So maybe once, the VLP, geofencing, and potential expansion to Uni 6 and 8 gets adopted, we may, reach kind of a plateau where there's just more minor adjustments for that band. But that's not saying that there's not still going to be work for both of us. I assume, we're going to be focusing on other spectrum bands at that point. Then, so yeah.
Okay, thank you.
All right. Do we have any other questions? I've one. This involves testing, real-world testing. I don't know if you saw Professor Manisha Ghosh talked in our 6 gigahertz panel yesterday. She's running, and you might be aware of this, I think she said the nation's largest test at 6 gigahertz with APs in Ann Arbor, Michigan, and Dearborn, Michigan. She also noted that, though, which is great to have them out there, and there's a lot of testing going on there, and I guess a little bit in South Bend near Notre Dame as well. But the question that came up for real-world testing around that was, that's great to have all those APs, but apparently in the Michigan scenario, there's maybe 5 incumbent fixed wireless, mission critical, and I think around Notre Dame there might be 1 incumbent. So the question that was asked on that panel was, what if that test occurred around where there's numerous incumbents doing mission critical, let's say Chicago, or where all the police department backhaul and all the utility backhaul and dam management and thing, all that was going on. And so the reason that was all being mentioned is, in order to get to real world testing, sometimes the incumbent becomes a guinea pig, and we don't want that. But at the same time, it would be great to have a federal budget or something going on where at the national labs in Idaho or somewhere where real-world type testing could occur with real APs, real incumbents. And now that all this other stuff's occurring, we're all super curious here because we're kind of geeks for that. And we also see that in the real world, often what's simulated or thought through, and often simulated with great intensity and great study, just doesn't turn out to be real. The real world has surprises for all of us. So that's sort of a long-winded way of saying, do you foresee any sort of federal budget for doing real-world test beds for all these new technologies? That's sort of the big question.
Well, I haven't heard directly or anywhere anyone's actually proposed a budget for that. People talk about how great it would be to have more R&D, but obviously, where's the money come from, right? And I haven't seen any proposals for federal money being budgeted for testing, either this type system or really in other bands either.
Okay, so I guess if we're gonna let that bubble up, we're gonna have to maybe go to the Hill and maybe bounce off of OET and see what, if you guys were king for a day or queen for a day, or whoever's running OET at the time, how would they shape it if they got a budget? That kind of dialogue.
Right.
So, One more question?
So,
You can introduce yourself.
Tom Taylor, I'm going to try to answer the question a little bit because I think there's a lot of work going on. Historically, we introduced model cities a while back, the concept of model cities, and it just didn't take. Nobody was really interested in a model city. It was difficult. But the NSF program, which is NERSCOM 4 tomorrow, is going to talk about national radio dynamic zones, which they have various funding opportunities out to run. And one of them is to establish an engineering and execution lead for just such a national radio dynamic zone where you test new equipment real time in a real environment safely. Now, what the program doesn't have is funding in the out years. But if we look at the national spectrum strategy and there is enough drive, you can see where funding in the out years could be generated or motivated by implementation of the national spectrum strategy implementation plan. So I think there's a pathway if there's need. I think the questions are asked enough, but no one's been motivated enough to throw money at it or even drive to have money put at it. NSF is opening a door with a little bit of funding if the EELs can prove test-worthy and the NERSCOM, SII nerds performers can develop some capabilities. I think we can open it up to real-world testing in many areas, urban and suburban. So, yeah, I think there's a lot of opportunity there, but people are going to have to speak up.
Thank you, Tom, for that. And that would be great if we end up with a pathway to manifesting real-world testing that's got the whole community, the entrepreneurs, the regulators, the visionaries, the Hill people, the Hill people. All right. With that, please, a round of applause for Nick. I really appreciate this. It's been decades of cooperation with OET, and we always appreciate it. And thank you so much. There's obviously a lot of preparation here. Our next panel is 11:15, and it'll be drones, sensing from RF sensing from drones. Thank you.